Okay, so we're looking at the topic transformations. Transformations. All right, so these are objectives that we're looking at right now. We want to identify the different types of transformations. So for this level of maths, we only have four transformations that we look at. We have translations, reflections, rotations, and enlargements. So then what we want to also do is identify and use the translation vector of a translation, locate and use the mirror line of a reflection. So that's going to be our focus for today. All right, so transformations. So transformations basically describe the change in position and or size of a shape. Okay, so when we talk about the object, that refers to the original shape. So there's a particular object that we are trying to transform. Now, when we transform that object, we're going to get an image. So after we transform an object, that's going to be its image. Okay, so it's like you have something, you get a copy of it, that's like the image of the original. Okay, so these are the four types of transformations that we're going to be looking at in our syllabus. We're going to have translations, rotations, enlargements, and reflections. So these are the four transformations that we have. All right, so we have some comparative measures of shape. So they are basically orientation. We judge them based on similarity, and we also judge them based on congruency. So basically, these are the measures that we use to compare shapes relative to each other. So in this case, we would have to describe an object to its relative image. So we want to know, how has the orientation changed from the object to the image? Or are they similar? Or are they not similar? Are they congruent or are they not? So now we need to understand what these words mean. All right, so the first one, orientation. So when we talk about a orientation, all right, so the first one, orientation. So when we talk about a orientation, it's basically when we see something changing around a fixed point. Okay, so orientation is like going around, and it's just going around a fixed point. If not a fixed point, an axis. So orientation around a fixed point is a rotation, and orientation around a fixed axis is a reflection. So if you look at this is around a fixed point. So imagine this happy face is spinning in this direction. Okay, so this here is a rotation. Now here, imagine you are looking at this, and this here is spinning around almost like a merry-go-round. Okay, just that you're looking at it straight on. Okay, so this is the merry-go-round, piece of the merry-go-round going straight around, and that is coming out of the axis. So let's think of something that you can think of. So say for instance, looking at this is almost like looking at a blender. Okay, you're looking straight at the blender, you know it's spinning around and around and around. It's around a fixed axis. So that is when we talk about reflection. Okay, so you imagine this flipping from here over here. Or even better yet, if you think of it as a book, imagine this is one side of your book, and this here, you flip the page over, that's a reflection. All right, so the center of your book is almost like the axis, the fixed axis. Okay, now this here is like you're spinning around like a fan. Okay, so that there is what we refer to as a rotation, because it's going around a fixed point. All right, y'all got it? Still working on it? All right, we ready to change now. Okay, so similarity. We say shapes are similar when all the corresponding angles are equal. So all corresponding angles are equal. All corresponding sides are proportional. Okay, so shapes are not the same size, but we expect them to have the same angles, and we expect the sides to be proportional. So if you look at this triangle compared to this triangle, the angle inside here for both of them is 60. So 60, 60, 60, 60, 60, 60. Wonderful. Now, if you look at this here, okay, this side is 5, this side is 15. So this here is 3 times bigger than this. So I would expect that all these sides would be 3 times bigger. Okay, so if this is 5, this is 15. If this is 5, here's also 15. If here's 5, here's also 15, because we are multiplying them all by 3. Let's just say by chance it was different angles, but they were the same angles for both triangles. Let's say this length for just for illustration, was 4, this would be 4 times 3, which is 12, because they are proportional to each other. All right. So if you look at this here, these would be considered similar again because they are different sizes. However, the angles are equal and the sides are proportional. So basically what that means is if you think of them being similar and meeting these characteristics, it's essentially saying we have a little brother, big brother, little sister, big sister. Just imagine they were like twins, but they're the same in terms of how they used to look at a particular age, but now that one just looks like the bigger version of this little one. So congruent. Two shapes are congruent if they are identical. Therefore, one shape is placed on the other, they exactly match. Okay, so congruent shapes are the same shape and size. Congruent sides or segments have the exact same length. Congruent angles have the exact same measure. So if you look at it, these here look like twins. So when I think of the word congruent, I think of twins. So they look the same. They could be oriented differently, but they're the same size. Alright, so the types of transformations. This is something you need to know because you need to know how to identify them. That's the important thing. You need to know how to identify it. So we have translation, reflection, rotation, enlargement. Alright, so the first one, translations. So translations map a shape to another position while keeping the orientation the same. Okay, so the translation vector describes a move made from object to image. So remember, our original shape is the object and our final one is the image. So moving from object to image, that is what we call the translation. So our object here moves 2 steps to the right and then 4 steps up, just like a vector. So we go 1, 2 to the right, then 1, 2, 3, 4 up. Now each point does the same thing. So then we go 1, 2 up, then 1, 2, 3, 4. Okay, so if I had to do this from scratch, let's pretend this image wasn't here. I would move 2 to the right and 4 up. So essentially this is how it looks like as a translation vector right here, a column vector. So x, remember we said x is going to the right twice and 4 is going to the right, is going up. Okay, so therefore that means we would go here 1, 2, then we go up 1, 2, 3, 4. So my first dot will go here. Then I do that for this here as well too. So I go 1, 2 to the right, and I go 1, 2, 3, 4 up. My next dot would go here. Then I do it for this last dot here. I go 1 to the right, 2 to the right to match this part. And then I go 1, 2, 3, 4 up. Alright. So then with these 3 points, I could draw my image. Just connect these dots and that's my image. This here is an object. We want to translate it. So it's just like a language. When you're translating a language, it means the same thing. So for instance, if we said, hola, ¿cómo estás? If you translate that, it means, hello, how are you? So it has the same meaning, it's just a different language. Now, when it comes to translations in maths, we're saying we have an object, which is like the original, and then we copy in that same image somewhere else, but it's going to stay the same orientation, and the size is going to be the same as well. So what we're saying is we're moving like vectors. So the translation, in order to move this, it was telling us we need to do this translation, which is 2 steps to the right, because 2 is positive, and 4 steps up because it's also positive. Alright, so what that means is each point we have to move it 2, 4. So for this first point, I'm gonna go 1, 2 to the right, and then we go 4 up. 1, 2, 3 up. So this is my first dot here. Okay, I'm moving this whole shape, but I have to do it piece by piece. You get me? So then this one here, now we go 1, 2 to follow this, and then we do what next?
Up by 4.
Up by 4. So 1, 2, 3, 4. So then this here is our next dot. Likewise, we have to do it for the other corner here, which is this one. So we go 2 to the right, then 1, 2, 3, 4 up. Does that make sense? Now with that information, I could then draw the triangle, because after doing all of this, I basically would have my 3 dots here. Okay, and then I could connect them. All right. Now, when we talk about the inverse, you're going from image back to object. All we would do is like what we spoke about the last time, we just do the opposite. So instead of going 2 to the right, we go 2 to the
Left.
lovely. And instead of going 4 up, we would go 4
Down.
lovely. So in this case, what we're trying to do is figure out what is the translation vector. So we have two objects here. Now notice here that these letters have A, B, and C, whereas this one has A apostrophe, B apostrophe, and C apostrophe. Now usually that's a way we used to denote that these points was the second ones. So for instance, this is the original A, B, C. You got it? Now this apostrophe here, what we refer to as prime. Okay, so then we say A prime, B prime, and C prime. So that's like the next addition or the image. So this is the object, this is a copy. All right, the object, and this is a copy, which we refer to as the image. Now, the key characteristic of a translation is a translation vector. How many moves did it make to the left or right? How many moves did it make up or down? So the first thing we need to do is figure out how much this one did. We have to move how many steps to the left from this A to get under this A prime. 1, 2, 3, 4. Okay, so we move 4 that way. We move 4 to the left, and then we have to go up 5. So because we move 4 to the left and then 5 up, this is where the A landed. We know that our vector, our translation vector, is -4, +5. So what do you think is going to be when we go from B to B prime?
4.
Negative or positive?
Negative.
-4. -4, then what? Then 5. What do you think gonna happen from C to C prime? Same thing. -4, +5. How did we get what?
How do we get 5 if the point by 4?
So we went across 1, 2, 3, 4. Then we went up 1, 2, 3, 4, 5. You got it? Lovely. So essentially, our translation vector for this shape is basically -4, 5. So usually in an exam, they ask you two things when it comes to a specific transformation. One, you have to identify the transformation. So in this case, this transformation is a translation. When it comes to translations, the next thing we need to identify is how many positions do we move? Do we move left, right, how many times? We move up, down, how many times? And that would essentially be what we are looking for when it comes to vectors. So we realize that we move -4, 5, which is 4 steps to the left and 5 steps up. So this basically tells us what's going on here. All right, that's how we describe a translation using its translation vector. All right. All right, so let's look at this one here now. Now we have a triangle, okay? What we want to do now is translate a new triangle. And this triangle that we have here is considered to be our object or image. Remember, the object is the original, right? The object is the original and the image is what comes from the object. So right now we have the object and we need to find the image. So the image works under translation 6-8. Now, who could tell me what 6-8 means? What does the 6 mean? What does the 8 mean?
6 across and 8 up.
I don't know what 6 across means. I know what 8 up means. What's 6 across?
6 going to the right.
And how you know it's 6 to the right and not left?
Because if we're going to the left, it would be negative.
Lovely. So we have to do this for each point. So we do the first point here. We go 6 to the right, and then 8 up. So 1, 2, 3, 4, 5, 6. Then we go up 1, 2, 3, 4, 5, 6, 7, 8. Next one. Again here. 1, 2, 3, 4, 5, 6. Then we go up 8. 1, 2, 3, 4, 5, 6, 7, 8. We do it for the next point. 6 to the right and 8 up. And then we have this point here. Okay, now that we have these 3 points, we can draw our shape. All right, so therefore we would have our image here. Does that make sense?
Yeah.
So we basically did 2 forms of how translations could come. They could ask you to draw a translation, or they could ask you to determine what the translation vector is. Okay. All right, so let's talk about rotations. So rotations occur when a shape is rotated around a center point. We mentioned this before. Rotations can be clockwise or anti-clockwise. Now, translation vectors, the key things that they had were translation vectors. Okay, so translations, the key things they had, translation vectors. Now, rotations, okay, rotations. What we look for when we're talking about rotation is the center of rotation and the angle of rotation. Okay, those are the key things for a rotation. Now, if you look at these two pictures here, this here would be the center of rotation for this here, and this guy here, the center of rotation is this dot here. Now if you look at it, this rotated 90 degrees, so that's what I call my angle of rotation. Alright, my angle of rotation, and I have to state what that means. 90 degrees where? Clockwise. Okay, so I want you guys to take this down. Right, so reflections. This is our third one. Reflections. So reflections occur when every point is the same distance from a central line. This special central line, we call that the mirror line. Okay, that's a mirror line. Okay, the reflected image has the same size as the original image, and all it is a reflection of one to the other across a mirror line. So if you look at this, you can think of this as what you learn in primary school as symmetrical. So just imagine if this was somewhat of a wing. You can see that this is the left side of the wing and this here is the right side of the wing. So they literally look like mirrors of each other. It's just like you, when you look inside of the mirror, it's like you're almost seeing yourself in the mirror looking at you, facing you. So it's like this here is looking inside of this mirror, and this here is a reflection looking back. So the last one, enlargements. So enlargements, we have a regular enlargement and then we will have what we call a negative enlargement. So let's look at the enlargement. So enlargements describe the increase or decrease of an object. So an object going to an image, you will see resizing. You will see that it can either become twice the size, 3 times the size, or maybe even half the size. So the key characteristics of an enlargement are its scale factor of enlargement and its center of enlargement. So let's look at everything so far. So translations, the important thing is a translation vector. Reflection, we want to look at the mirror line as well as, that's it basically, the mirror line. So for the reflection, we want to look at the mirror line. For the rotation, we're looking at the center of rotation as well as the angle of rotation. And when it comes to enlargements, we're looking at the scale factor of enlargement and its center of enlargement. So what are those fancy terms? So if you look at this, here's the center of enlargement, and when you take this in original shape here, as you can see here, this one here is twice the size of this. So eventually we're going to learn how to do this and what this entails. But for right now, just know that the center of enlargement is at this particular point. Okay, as we develop and grow in this lesson, you guys are going to understand how to actually get. So negative enlargements. So these are resizing that occurs on the opposite side of the center of enlargement. Okay, so unlike what we saw before where it was on the same side of the enlargement, these are on opposite sides. Alright, so this is another interesting thing that we learn as well in this topic. Okay, so tell me before we do that, what are the types of transformations?
Rotation, reflection, enlargement, and translations.
Lovely. Alright, so this first one here, it kind of tells you, but what is this transformation here?
An enlargement.
Lovely, an enlargement. Now, who could tell me what is the center of enlargement?
0, 0.
0, 0. Now, if you look at this, this here has 2 boxes from this point to this point, and this one has 4. 1, 2, 3, 4. So that means this one is twice the size of this. So the scale factor of this is 2, meaning that this here is twice the size of this. And if you notice, you see we have our A prime, B prime, C prime, D prime, and so forth. So this is our object, this is our image. Okay, good. Somebody else. What is this one?
Is that translation?
it could almost be one, but the only issue is that the size is different. So if the size is different, what is it?
It's enlargement.
Enlargement.
Lovely, enlargement. All right. Now, can someone tell me what is the center of enlargement here?
Two.
2, 2. And if you look at this, the bottom of this is a what? 1, right? This here has how much?
2.
2. So that means that this is double this. So the scale factor of this is also 2. All right. Good. Now, interesting. Take a look at this. Take your time. So what I do when I go through this, I go through a process of elimination. So I say, is this an enlargement? That's the easiest one to know. If it's not, then you know, oh, it's not. Then you ask yourself, is this a reflection? Does it look symmetrical? Maybe not. You know, and you go through that phase of trying to figure out what it is. All right. So let's see what this one is. What do you guys think this one is?
Rotation.
That is correct. So it is a rotation. Now, if it was a reflection, even if it was along this line here, you would see this point up here as well too. Okay, it would look somehow like it mirroring each other. Now notice how this is up this way and this is down that way. So that's my giveaway. That is not a reflection. Now you when you see a reflection, you're gonna know it's a reflection. What's this one here?
Is that a reflection?
Rotation.
A rotation. It is a rotation. It looks close to a reflection though, but it actually is a rotation. Notice again how, see how it looks different? This one is that way, that one is up that way. Because you have to think of it, if it's a reflection, somehow it's gonna look like it's looking into a mirror. Okay, and that's what makes it a little tricky. Now this one, what you guys think this one is?
Translation.
Translation. So this is an object, it looks like this, and you see it's literally like the same thing. Okay, so let's go through those again. So this first one was a
Enlargement.
this one here is a
Enlargement.
this is a
Rotation.
this here is a
Rotation.
this one here is a
Translation.
no, look at this. What is this one?
Is that also a translation?
Anyone else thinks it's a translation? Don't be scared to get it wrong, guys. That's how we learn. You gotta mess up to get better.
That's the reflection, correct?
What makes you think it's a reflection?
I see like
Okay, no. Good. You see the same thing twice. But is it a mirror? Does it look like a mirror of each other in the sense of like symmetrical? Does it look like if you draw a line between them, what you see on the left is like the flip on the right? So let me show you now. If this was a reflection, just so you could see the difference, it would look like this. This would be like that for that first one, right? And then the next one would look like that too, but just this way. You see the difference now?
yeah.
You got it now, right? Because if we had a line here, it looks like they're looking in a mirror. Okay? Now notice how this one is. See how they're looking at each other? Therefore, this is a what?
Translation.
Yes, the original answer. Alright? When I press y'all, is to see how confident y'all are. Okay? So this one in the corner, what is this one here now?
That's the reflection.
Lovely. This is a reflection. So you guys could see it now. You see how this is? This here is a line that is a reflection. Okay, now this is how the reflection works. If you look here, this is a mirror line that I just drew. Now look, this here is one dot up. Okay, it goes up one. This goes down one. Alright. This here is 2 spaces away from the mirror line. Likewise, this one is also 2 spaces away from the mirror line. Now here is 1, 2, 3, 4 spaces away. Just like this one here is 1, 2, 3, 4 spaces away. Alright. Alright, so what is this one here?
Reflection.
Reflection. Lovely. Reflection. It is indeed a reflection. And what is the mirror line? The mirror line is the y-axis. Can you see? So again, this here is how far away from A. How far is A away from the mirror line?
Oh, 2.
2. And as well as this one. So this is 1, 2 spaces away. Here is 1, 2 spaces away. This one here is 1, 2, 3, 4, 5 spaces away. Likewise, 1, 2, 3, 4, 5 spaces away. Alright, what is this one here? What's this transformation?
Negative enlargement.
Enlargement. This is an enlargement. What is this one here?
Enlargement.
Enlargement. What is this?
Translation.
Translation. Once you see it looks the same orientation, ain't change up, then you know it's a translation. What is this here?
Translation.
Translation.
Reflection.
Reflection. Notice how C is looking at C, A is looking at A, B is looking at B through a mirror line. This here is what?
A reflection.
Lovely. Reflection. The mirror line is here. Okay. B is looking at B. A is looking at A. We have 1, 2, 3, 4 steps away from the mirror line. 1, 2, 3, 4 steps away from the mirror line. What is this one here?
Rotation.
Lovely. All right. This here, what is this one here?
Rotation.
All right. Somebody else. What is this one here?
Enlargement.
Lovely. Enlargement. Somebody else. What is this one here?
That's also an enlargement.
Lovely. What is this one here?
A translation.
A translation. Good. Now, how can we work out a translation? Now, if you look at it, see how this literally look like twins? If you see it look like twins, like they lean in the same and so forth, translation. Okay? Now, check this out. What's the translation vector here? So, in order to figure that out, we figure out how we got from A to A prime. So, we went 1, 2, 3, 4 to the right. So, that's 4. And then after we go down 1. So it's 4, -1. Okay? Likewise with this, see here we go 1, 2, 3, 4 to the right, and then 1 down. 4, -1. To get from B to B prime, 1, 2, 3, 4 to the right, and then 1 down. 4, -1. What's this here?
Translation.
Now, I want y'all to figure out what the translation vector here is, and then I'll go through it with you. So how are we getting from this shape here to this shape here?
Vectors 2, 3.
Yes, 2, 3. So we go 2 to the right, 1, 2, and then we go 3 up. 1, 2, 3. So it is 2, 3. All right. So what do you think this one is?
Translation.
Translation. Yay. Good. What is this?
Enlargement.
Lovely. What is this?
Reflection.
Flexion. You see the symmetrical kind of look? What's this here?
Reflection.
Reflection. What's this here?
Rotation.
And what's this one here?
Rotation.
Now notice I put 26 of these questions. The reason why, it was very intentional. The whole point of doing all of these questions here is because when you see it over and over and over, you start to kind of get the concept of what it is you're looking at. Okay, so what is this one here?
Reflection.
Reflection. Good. What is this here?
Rotation.
So I think the trickiest one is always remembering the rotation, but as you can see now, it looks odd. You see how this look like you gotta turn your head to see this looking the same? You gotta rotate your head to that rotation, you know? Same thing here, rotation. Now this here, look like you gotta flip it. Reflection, alright? Reflection again. Okay, y'all get it, right? Translation is literally like you move from here, and it looks exactly the same. It looks like a copy and paste. Copy and paste all the way. Alright, so this here that I sent to you guys. So I want you guys to work on these. Now the thing is, whenever we're doing the translations, what we do is we add this to each point. Okay? So it's similar to what we are doing when we go 1, 2, 3, 4, and then we go up 1, 2, 3. So -4, 3. So this is a translation. So essentially this coordinate here is 6, 1, right? So 6, 1. If I was to add 6, 1 to this, I'll get 6, which is the x component, plus the -4, which is going to give me +2. And then 1 plus 3 is 4, which is giving me 4 here, which is 2, 4. So as you can see, 2, 4 is right here. So I move from 6, 1, which is this, to the coordinate 2, 4. Now I would be able to do this if I did not have the picture because I just added here. So likewise for this part, that's what we have to do. We have to add this -5 plus the 8, then the 3 plus the 7, and likewise for each point. Okay? So, to get us rolling, I want us to start on this here. So this is just a multiple choice. So what it says is, what will be the new position of the given point after translation of 3 units right and 2 units down? So we are talking about this here. So what we are doing is, we're going 3 units to the right. So we go 1, 2, 3, then I go down 1, 2. So I expect the point to be literally right there, right here. So that means my answer is this. Alright? So you use this as your reference. So 4 units to the left, 1, 2, 3, 4, and then 4 units up, 1, 2, 3, 4. Alright? So you guys could do this on, if you print it out, you could write on it and then send it to me as you do it. Or if you have an iPad, you could write it on there, or a tablet, write it on there and send me screenshots. Or you could also edit it on your phone and send me screenshots as you go along. All right. So let's start working on this. This is in the chat.